In this guide, we shall replace the cloth component on a player model in GTA5. The replaced component will have a cloth simulation technique on it. Cloth simulation technique is enabled inside a metadata file. That is why you can't just create a new component and enable cloth simulation on it. You can replace the component that already have a cloth simulation enabled. Cloth simulation availability is controlled by YLD file next to the YDD file. If you wish to replace the cloth component and have a cloth simulation on it, an initial file needs to have a YDD and YLD file. In this guide, I shall replace the upper 29. Start ZMode and import the YFT file. Make sure to turn off Slice to Parts option. This is the skeleton model of the player. Rename it to .global. I resize bones, then import the YDD file, slice to parts off. We have upper 29 and .mesh. We have a .mesh in global. Delete, we don't need it. Mesh is a component and has L0 level. Turn this on. This is an original cloth component. It's hardly seen, so I turn textures off. Then you can load the YLD file. This is the actual cloth object. Make sure you have an associated branch in hierarchy. For example, you can import the YLD file for any arbitrary scene. You need YDD file being loaded before you can load the YLD file and import the YLD. We've got a cloth object, the actual cloth simulated object. This is the object the game will simulate cloth on. These points will be moved by wind and by player movement. These points will control the mesh they belong to. To make cloth simulation on the final object neat and accurate, it's strongly recommended for the cloth object to match geometry as much as possible. However, cloth object is restricted in a vertices count. You can't exceed 255 vertices. So you can't just use a part of this object for cloth simulation. For example, if you pick the lower part of vertices, you will see quite a lot of vertices. So the cloth object needs to be created. Yet another thing the YLD file brings to our scene is collision objects the cloth will collide with. If you don't have any collisions, the game can move these points this way straight to the leg. And I doubt this is what you would like to see in game. Collision objects are loaded onto skeleton model and turned on by pressing button call. Here they are. You see collisions for legs and several collisions for spine. Let's look the hierarchy. Pelvis, right. Legs have collisions. Spine 0, spine 1, spine 2, and probably spine, yes, and spine 3. We shall use original collisions. It's not a problem to create new ones. Mind you can use only capsule models. Something like this. Dummy helper, properties, shape, capsule, size. Something like this. Yeah. Then this dummy object can be used as collision. To replace cloth component, I shall use the model from WatchDogs. Okay, you can see it stand a bit up and face in the wrong direction. What shall we do? We shall move and rotate. We shall move and rotate the skeleton. Sorry, it's here. The skeleton. We do so by right clicking and turning the setup mode off. Also, we turn the inverse kinematics off. Then I select the pelvis and turn auto selection off. Now I can move it. I can rotate and match the original mesh as much as possible. You can see player hands are not matching. We shall rotate screen X and Y, rotate arm bone. I tap Control key so I can pick different objects under cursor until it match the original object. Same you do on the second arm. Also make sure the side view is alike. Okay, and top view, of course. Is matching off. It's not matching on top view. We need to rotate arm bone over here. Deselect, pick arm bone and rotate it slightly to match original setup pose. The mesh is adjusted and I use rigging skeleton unbind tool. Unbind. This will save geometry setup, so you can delete this skeleton as unneeded. Adopting this cohort model onto micro component took a pretty long time, so I load the model that is already prepared. I use file merge and load the file I've been messing with for about 3 hours before recording this video. I load mesh and cloth objects. I will show you. This is the mesh object I have created and a cloth object. Few words about the cloth object. First of all, I've told this already, we are constrained in a count of vertices. Also, it has to match the controlling object as much as possible. Another limitation, the controlled mesh should be pretty thin. This code is pretty thick. For cloth simulation, it's not a thin drape. so it might have some artifacts, and you will probably see these artifacts perfectly. The cloth object should be thin like this. I don't want to move all these points inside the cloth object. It has properties. Oh, one moment. P configuration general compatibility settings and set to GTA5 if you haven't set it already. Once you do so, you will have a specific settings for example, points like this. GTA5 options. So the cloth object has user-defined options, which are freedom, several levels of freedom. Level 1, level 2, level 3, level 4, 5 and 6. We have 6 level of freedoms. The point with level 3, which is 0.5, will be half controlled by skeleton bones and half controlled by cloth simulation. The point with level 6 will be controlled by cloth simulation only. Consider this as 100%. You assign levels onto points. For example, points in this area should be quite free for cloth simulation, for wind effect. So I guess they have freedom of level 5. These belt tails have a level 6. So they will swing on a wind and swing while player is riding a bike. The first and the very important thing, at least one point, or perfectly 2 and more points, have to be linked to the skeleton and should not be affected by cloth simulation. We call them static points, the points that will not move by cloth simulation and will be controlled by skeleton and its bones. This model have pretty many static points, including this point where the belt starts, these points on the back. These all points are static and will not move by cloth simulation. If you fail to assign static points, the entire cloth object, all these points will immediately fall through the ground. You will not see cloth on a player or a pad model. So at least one static points have to be assigned. Other options are a sort of trial and error. You can change levels, you can change elasticity levels, oh, not elasticity, response levels, and see an in-game effect. For simplicity, you assign levels onto points, and actual level values are controlled on a cloth object itself. So if you are not satisfied with cloth simulation freedom of points, you change these values and see an immediate effect on entire cloth object. Same goes for response. Response, I assume this is something like the distance the cloth point can be moved on each iteration. If you set a small value, the point will move to the small distance while the cloth simulation is evaluated. If you set higher value, for example, like this, the point will be able to move much further. So we have two levels of response, one for points that will have a low level of movement and another For points that will have a higher level, we can use up to 6 levels. As you can see, each point might have a response level 1, 2, 3, up to 6. Mind the cloth object as well as mesh object have to be bound to the skeleton. So we turn it off. We select mark, right click on skeleton base and use rigging bind tool to bind the mesh and mark and bind cloth too. It is essential to assign correct bonus for the static points, the points that will be controlled by skeleton. We do so by copying weights from original mesh object, if possible. So we use rigging influence copy. We copy original mesh influence onto cloth. This is solely for static points and points with low freedom value. So the cloth object is ready, but the mesh object is not. Because you have to specify vertices of mesh object that will be affected by cloth. The lower part of the code is cloth controlled. You can see it in options. Cloth control properties, I will explain. Affected by cloth rather than skeleton bones. So even these vertices are affected by leg bones. Availability of this option will enable a cloth simulation on these points only. Unless you set this option, the point will not be affected by cloth. We don't need original mesh and cloth anymore. These objects can be unlinked, renamed to unused, why not? And the newly created component is moved over here. Ensure it's bind properly. You see skeleton is highlighted in lime color. Mesh is bind, cloth is bind too. One more point to discuss is a collision. This long code requires collisions on left and right curves. So we create a copy here and here. We create copy and put them into proper skeleton branches. This one is, this one is left thigh and goes to left calf. Select and move. Select and move. Okay. And this one goes to right calf. Select and move. Front view. Front view. The size is pretty big. Let's change it to something like this. Okay. I think it's okay. You can create collisions for food. You can create collisions for spine and arms and head if you need. Now we can export the YDD model. Export loads all, skeletal turned on, and export. Okay, and we export the YLD file. This is our cloth and collisions. One more thing, if you replace the mesh component with a high detail geometry, make sure to change the base value on the component. Something like 4 and 2, why not? I omit the questions about materials and textures why I need to assign and replace in the game. It's not a scope of this particular tutorial. So the model is exported. Now I use OpenFormer to replace pet component. Player 0 upper 29 YLD file is located in this folder. However, YDD file was fixed in some patch later. So I put YDD, YLD and replaced texture file into the patch and test the game.